Hi, my name is Sebö. Welcome to the Texas Instruments booth here at Electronica 2014. You're here at the sensing booth. What we're showing is a couple of new sensing technologies that Texas Instruments has released. First off, we have inductive sensing right here. So the inductive sensing is shown with the first inductance to digital converter, which is called the LDC 1000. We have the evaluation kit right here. You can also see two of our demos that we're showing here. The first one is called Touch on Metal. It has integrated haptics as well. So with the Touch on Metal, what we're showing is actually the deformation of metal. When you touch it just slightly, you are bending it by a few micrometers and therefore changing the inductance of the coil that we are measuring with the LDC 1000. So on the screen you can see that you can have a very good response, very sensitive, just with the slightest touch on this one. Now moving on, we have a weight scale based on LDC 1000. You can see that on the PCB we have a coil and on top we have the target. And based on the characteristics of the springs, we can determine the exact weight of the glass with water. So moving on, we have capacitive sensing over here. The very first demo that we're showing here is a liquid level sensing demo. We have a 4-channel device, the FDC 1004. 2 channels are used to actually measure the level of this tank. One strip is the reference strip, which is used to determine what kind of liquid you have in the tank, be it either water or is it even air, so it's empty. Together with the temperature and the second strip, which determines the full level, you can determine the actual level within the tank. In addition to that, since we have more than just 2 channels, we have another proximity sensor right here. So this one is actually used to activate the whole system and then enable the pouring of the water. So moving on over here, we are showing a capacitive sensing based proximity detection demo. So what you can see here is when you approach it with your hand, you're actually switching on the illumination of the LCD display. Now this is not that spectacular, but what is really interesting is the kind of sensing element that you can use with this. So you do not have to use any sort of like PCB for the sensing element. You can even use conductive paint or ink, just like this one. This is a nickel paint that we have just put on top of this PCB, so this works. As long as it's conductive, it'll work with this device. Due to its high sensitivity, there's no problem to use any shape, any kind of conductive sensing material that you can use with this device. So over here you can then see our evaluation modules for this device. This one is the evaluation module for the FDC 1004, which is the capacitive to digital converter. It is using 2 channels right here, but obviously you can snap it off and use it for other with multiple channels, just like in our previous demo. Finally, we also have the HDC 1000, which is our first humidity sensor actually. The basis is the same for the evaluation module, but the part is actually what's really interesting about it. So it's a new device. It's actually the smallest humidity sensor in the market. It's got the lowest power consumption, and it's got a new way of sensing the humidity actually. Usually on the existing devices you have the window for the polymer at the top, which means that you collect a lot of dust on this one, which lets the part age quite quickly. In our case, we have the polyamide, which is a sensing element at the bottom. So we're measuring the airflow that is underneath, that goes through underneath the device, and therefore are not prone to that. Aging is a lot less of a concern. So that's overall some of our new technologies that we have in sensing. Obviously, Texas Instruments has a very broad portfolio in sensing. We have a lot of temperature sensors, current sensors, you name it. There's all sorts of sensing technologies in our portfolio. Thank you very much.